Hello everyone, welcome to OJ Patterns. Today we will be understanding tape measure. So we're going to be understanding our tape measure very well. So before we go into much details, please don't forget to subscribe, like, and share this video. A tape measure or measuring tape is a flexible ruler used to measure length or distance. So it consists of a ribbon of cloth, plastic fiber, or metal strip with linear markings. So basically, a tape measure, like your measuring tape, it can be um, made from fiberglass. It can be metal strip. It can even be cloth. I've seen a tape measure that was made with fabric. But the most important thing is that all tape measure has linear markings. So the linear markings will make you know that oh, this is a tape measure. That means you use it to measure whatever you want to do. So let's go on to two system of tape measurement. So we have the imperial system of tape measure and we have the metric system. The imperial system is also known as the inches. That's where the one we used to measure yards, feet, and it's in inches. So this is imperial and this is metric. So this is imperial, which is in inches, and this is metric. So let's go ahead. Next, another thing we need to understand is that our imperial system, that's the imperial tape, which is the inches, it comes in decimal or fraction. So it can be both in decimal and fraction. So we're talking about fraction measures length in fractions of an inch. That's when you're talking about fractions, you're talking about it having like, let's say like 1/4. This is fraction. 1/2. This is fraction, which is also half an inch, and so on. So we're talking about decimal. 1/2 is half an inch. 0.5 is also half an inch. So this is decimal and this is fraction. So they are both systems that are under the imperial or easily used. Okay. So 1/2 is fraction. So any this thing that has both numerator and denominator. Numerator and denominator meaning if it's let's say if it's let's just say 3/4. This is numerator, this is denominator. So the up one is numerator, the bottom one is denominator. So that means it's in fraction. But anything that has to do with 3.2, 1.5, this is decimal. So it works like that. So moving forward, we're going to be looking at the tape measure. Here we have two tape measures. Let me place them side by side. If you check the linear markings now for the pink one, our linear markings here is 8. For the white one, the linear markings there is 16. So let's count together. Let's count the pink. Now, because I have a stopper here, I'm going to count from here. So from here now, this is going to serve as 0, the straight line going across, because we can't see the edge, so I'm not going to start from here. So this is 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8. So that means this tape measure is by 8. That's 1/8 tape measure. Now, for the white one, let's look at it. We're going to count our linear markings. Now, this is 0. So 0, you're not going to count from 0. You leave 0 and you start from the next number, from the next linear marking. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means the pink tape is 1/8. Why the white tape is 1/16. They are both in inches, they are both imperial system, and they are both correct. So if you place 1 to 1, you see they both fall in the same line. So I'm going to quickly sketch out this for us to be able to understand it perfectly. Okay, now I'm going to sketch out the 116 tape measure boldly so that we can understand it. So I've drawn my line. So this will be my 0. So don't forget, I told you linear markings would have 16 at the end of the day. So I'm going to be sketching out the linear mark. So this is the first one. So the first linear marking from 0 is going to be 0.0625. So what I'm saying in essence is that the distance between 0 and the first linear marking on your 116 tape is 0.0625. So we have 0.0625 as the first linear marking. So this, what I drew out now, what I'm drafting out now to work with, is going to be bigger than what you have here because I want it to be visible. So I'm trying not to use this tape to explain because it's very tiny. So I'm going to draw out the exact 16 linear markings that you have here. That's from 0 to this. This is what I'm drawing out. So I'm going to be making it bold for you to see so that I can also write and explain. Now in decimal, this part is going to be in decimal. And here is going to be in fraction. So I'll be writing it out for us to understand both. Now the distance between each linear marking, the distance between each linear marking is 0.0625 in decimal. So what I mean in essence is from this to this is 0.0625. If you add another 0.0625 to it, you get the next fraction. So that's how it works. So it's the distance I'm calculating now between each linear marking. Now after the first, we'll move to the second linear marking and we would have 0.125. How did I come across 0.125? I told you each distance is 0.0625. So I'm going to do the calculation for you to see. We have 0.0625 plus another 0.0625 would have 0.125. So that's our second decimal. So we have 0.125. Now if you add 0.125 plus another 0.0625, we'll get 0.1875. So that's our next linear marking. So I'm gonna that's 0.1875. So as we are working the decimal, we'll be doing the fraction side by side. Now for fraction, don't forget we have 0.0625 here. This in fraction is going to give us 116. That's 1 over 6. 1 over 16 in fraction. Now I'll be doing the 116 and 1/8. I'll be explaining them in it. Let me bring this. Please note, we have 1/8. 1/8 now. How we go 116 is the one distance between from the first linear marking to the next one for your 1/8 tape measure is 0.125. So if you divide 0.125 into 2, you will get the mid part, which gives us the 116. So if you check, you have 1/8, and they divided it to get 116. So you have more of the linear markings here. So I'll be working on both. Now we have 0.1625. Don't forget I'm using 116. Now after that 0.0625, the next one is 0.125, which in fraction would give us 2 over 16. Now this would also be 1/8, 1 over 8, because this will be the first 1/8 linear marking. This will be our first 1/8 linear marking. So I'm trying to work side by side so that we can understand it perfectly. Okay, we have 0.1875, and this would give us in fraction, this would be 3 over 16. You see how it works? Just flow with each linear marking. 3 over 16. Now we have 1/8. Now for 1/8, now this would be empty. Don't forget, 1/8 is you miss one, you get the next one. That's how it works. So let's go to the next linear marking after 0.1875, and we would have 0.25. We all know what 0.25 is. 0.25 is quarter of an inch. You see, so we have the decimal is 0.25, and normally we'll do it 1 over 4. But in terms of fraction for 116, 0.25 will give us 4 over 16. So in terms of 116 fraction, you count all of them 1, 2, 3, 4, 5, 6. See, it just flows. See, this is 1, this is 2, this is 3, and this is 4. Now we've got 1/8. That means we'll mix the next one and go to the next. And this would give us 1 over 4, which is quarter, which means quarter of an inch, which is also quarter of an inch. Next, we'll move on to the next linear marking. After 0.25, I told you, remember what I said, that each linear marking, the distance between each of them is 0.0625. So what I'm going to do is add, just for us to understand that we're on the same page. So I'll do 0.25 plus 0.0625, and we'll get 0.3125. So that's our next decimal, 0.3125. Now in fraction, this would be 5 over 16. So fraction, just keep counting 1, 2, 3, 4, 5 like that till we get to 16. So this will be 5 over 16. Now in under fraction, under our 1/8, we'll miss this one to go to the next one. So let's go to the next linear marking, and we would have 0.375. 0.375. Don't forget to get each of the decimal points. You have to add, like what I did was add 0.3125 plus 0.625. So I just added them together. To get 0.375. So we did 0.3125 plus 0.0625. So you have to add the exact number. Now under 116, this is going to be 6 over 16. I said 116, just keep. And under 1/8, this is going to be our 3/8. 3/8. So this is 1/8. The second one is the quarter, which is 1 over 4. So if you want to count it like that, you're just going to call it 1/8, 2/8, 3/8. So you just keep working like that, but this is quarter, so you just have to label it as quarter. So after quarter, we have 3 over 8. And then we'll go to the next linear marking, which is 0.4375. Under decimal is 0.4375. Now under fraction, under 16, we have 7 over 16. It just keeps going that way. We have 7 over 16. Now we already have 3/8 under 1/8 measurement, so that means we'll miss this and go to the next. And after 0.4375, we'll have our next linear marking, which is 0.5. 0.5 is half an inch, and under 116, it will be 8 over 16. 8 over 16. Under 1/8, it will be half an inch. That's 1 over 2, which is half. Which is half. Don't forget, we have 1/8, we have 1/4, we have quarter, we have 3/8, we have half. And we'll move on to the next one after our half inch. And the next is, so all I need to do is add 0.5 plus, you add 0.5 and 0.0625, you get the next one. So next one we'll have is 0.5625. And then from here, the fraction of this under 116 would be 9 over 16. 9 over 16. So we've gotten under 1/8. After the one, remember what we said when we were working with 1/8. After one linear marking with 1/8, you miss the next one to go to the next. And then this here would have 0.625. 0.625, and this under 116 will be 10/16. 10 over 16. And 10 over 16 under 1 8 will give us 5 8. Will give us 5 8. That's 5 over 8. Next, we'll move on to the next linear marking. The next linear marking after 0.625 will give us 0.6875. Remember what I said, all you need to do is whatever this thing you have, you need to add 0.0625 to get the next one. That's just how the decimal part works. Now for the fraction under 116, we'll have 11 over 16. We'll have 11 over 16 and we'll move forward. Next, the next linear marking would have 0.75. 0.75 under 116 will have 12 over 16. Now we would have measurements under 1/8. Under 1/8 is going to be 3 over 4, which is 3/4. Which is 3/4. After that, we'll have the next linear marking. And after 0.75, if by the time you add 0.0625 to it, you'll get 0.8125. So under fraction, and we'll go to our 116, here will be 13/16. So 13 over 16, and then we'll go to the next linear marking, and then we'll have 0.875. 0.875 under the fraction of 116, we'll have 14/16, 14 over 16. We'll have 14 over 16, and under 1/8, we would have 7 over 8. That's 7/8. Okay, next we'll move on to the next. We would have, by the time you add them up, you have 0.9375. 0.9375 in fraction under 116, we have 15 over 16. And we would move on to the last, which is the 1 inch. Now this is the 1 inch. So I'm going to do a quick run through. Now what we just did now is the 116, because it's actually, it has more division. Now we did 116 and 1/8. We have both the decimal and the fraction. Now 1/8, if you check, if you count 1/8 from your 0, if you count 1/8 from your 0, you would have, let me just use from 1 because this is blocking it. So this is going to serve as my 0. So this is 0, and this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8 linear markings. Now take the white one, you count. Now this is 0. 0, we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 116. So it's 116. So what I did was I drew out all the linear markings on 116 out, so that we'll start explaining the distance between each linear marking. So this is what we have. So if you check, let's count. Now this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that was what was drawn out. Now each linear marking, we have the decimal, which is 0.62. Just as I explained, that decimal comes in points. It will have points as 1 point something, 0 point something, or 2 points. Once it has 2 points, then I just know that that's decimal. And fraction has numerator and denominator. So fraction has numerator and denominator. So we have 116 and we have 1/8. So both 116 and 1/8 have numerator and denominator. So both of them are fractions. So each linear marking, the distance between each of them is 0.0625. So let me just do this. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 0.625, and 0.625 in decimal is 1 over 16. Now we have 0.125. 0.125 is 2 over 16. So you see, under 116, we can count 1 over 16, 2 over 16, 3 over 16, 4 over 16, 5 over 16. So you just keep going till we get to the 16th, the 16th linear marking. Now under 1/8, so because you have 116, so 1/8 is it will pass each of them to go to the next. Under 1/8, we have 116. Under 216 is where you have your first 1/8, because even your tape, it shows that the distance here is 116, and then after it you have the first 1/8. Now after 1/8 you miss the next fraction, and then you go to the next one, which is 416. 416 is quarter, and 416 is like 2/8. So but because it's quarter, we just need to write quarter there. Now if you for it to help, after, now this is 1/8, this is quarter, which is also 2/8. Now this is 3 over 8, this is 4 over 8, 5 over 8, 6 over 8, 7 over 8, and then the 8. So that's how it works. But because we're going to be working with quarter, half, 3/4, and then you have the whole number. So that's why we have 1/8 and we have quarter. We have, after, normally when you're supposed to have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So you see, it even works. But we need to write out how it works. So we have 1/8 and then we have quarter. So that 1 over 4 is the same thing as your 2 over 8. So that's how we now have 3/8 as the next one. So 3 over 8, and then you have half an inch. After half an inch, you have 5/8. After 5/8, you have 3/4, which is 6/8 too. And then you have 7 over 8. Okay, now, so let's look at another method of achieving this. Okay, an easier method, I would say. So if you don't understand the first, you should understand this second one. So for you to get your decimal value, if you can't remember the 0.0625 for you to add to get to the next one, what you should remember is, now don't forget your linear marking is by 16. For you to get your decimal value, what you can do is you do 1 divided by 16. If you do, let's take it back, 1 divided by 16. If you do this, you get 0.0625, which is the value, which is the decimal value there. So now, if you can't remember that one and you're trying to get the next one, do 2 divided by 16, 0.125. So that's your decimal. Now, if you can't remember and you want to get the third decimal, all you need to do is 3 divided by 16, and we'll get 0.1875. So that's how it works. I hope this can help out. So all you need to do is just divide the number by 16. Now you're trying to get the fifth linear marking. All you need to do is 5 divided by 16, and you get 0.3125. So this is what we have here. So you see, that's how it works. I think this is actually easier, but it's best for you to know both and understand it. Okay, next, let's look at the 1/8. Remember what I was saying? 1/8. So because we can't do 1, 2, 3, 4, 5. So what you need to do is understand and know how to divide it. So let's look at this. So we have 1 over 8. Now you need to divide each of the both the numerator and denominator by 2, but you can't divide 1, Abby. So remember I said this is 1 over 8. The next one is supposed to be 2 over 8, but it has already been divided. That's why we have 1 over 4 as the quarter. So let's look at this. We have 2 over 8, which is supposed to be here, 2 over 8. Now, since you have 2 over 8, you can divide the numerator and denominator by 2. So 2 in 2 will give you 1. 2 in 8 will give you 4. That's how we come across the 1 over 4. Now, the next one is 3/8. 3/8, now, because this is odd number, we can't divide it by 2. Because, of course, 2 cannot go in 3. You have remainder. So you have to be able to divide the numerator and denominator by 2. So we'll leave 3/8 and we'll come to the next one. Remember I said the half is also 4 over 8. So the reason why we're doing this is because it has already been divided. So let's say we have 4 over 8. Now 2 into 4 will give you 2. 2 into 8 will give you 4. You have 2 over 4. Now, the 2 over 4 can still be divided by 2. So what you need to do is divide 2 into 2, you get 1. Divide 2 into 4, you get 2. That's how we come across 1 over 2. So you have to divide it to the smallest number you can get, the smallest odd number. So we have 1 over 2. That's how we come across our half. So if you check the ones that we're not saying, they like 2 over 8, 3 over 8, 4 over 8, and not because we can always divide. So, and then we have 5 8. After 5 8, remember here it's supposed to be like 6 8, which is 6 over 8. So let's do 6 over 8. 2 in 6 will give you 3. 2 in 8 will give you 4. So that's how we come about 3 over 4. Now 2 cannot divide 3 anymore. That's why we wrote 3 over 4, which is 3/4. And then we have 7 8, which cannot be divided by 2. And then we have the 1 inch. I hope this helps out. So under 116, we have from 0. So you count your 0 from here to 16. And then we have all of it played out. Now, moving on. Let's talk about let's quickly just go through the centimeter, which is the metric system. The metric system is actually quite direct. Now, for metric system, we'll have, let me use this. Now you can see your 0 for metric system. This is 0. So you can count each linear marking. If you count from 0 to 1 here, it's going to be 10. So this is 0, this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, and this is the 1. So that's 10. So from 1, we have 1.12. So the metric system actually very direct, so it just works easier. So I need us to go through the both the imperial and the metric system very well to understand. So let's just quickly look at some types of tape measure. There are different types of tape measure. We have the long tape, we have laser tape, we have steel tape, we have fiberglass, we have retractable tape, we have digital tape. Most of those tapes are used by engineers, construction workers, and surveyors. So, but the regular one we know is the long tape, and then we have the spring return. You know, the one whereby by the time you pull out and you use the mechanism, it goes back in. That's the spring return tape. So normally tape measure for dressmaking is usually flexible and it does not stretch out here. So it's just flexible, like it can move around, but it doesn't stretch out. But tape measure for like carpentry are stiff. If you know the carpentry tape is stiff, usually they have to retract it by themselves and that. Let's just look at some metrics and imperial conversion. So 1 yard is 36 inches. Let me pull this a bit close. 1 yard is 36 inches, makes up 36 inches. Now, 1 meter makes up 40 inches. Don't forget, as I said earlier, that imperial system, we use it in yards and feet. And the inches. So 1 meter consists of 40 inches. Consists of 40 inches. Now this is inches. You know, the symbol of inches is the two inverted commas. Wherever it is, you know, is inches, and or you can write it out fully. Now 1 meter consists of 40 inches. Do you know that 1 meter, 40 inches, 1 meter also means 1 yard and 4 inches? So if I write this, 1 yard and 4 inches also means 1 meter. So this being this in the sense that 1 yard is 36 and it says 1 meter is 40 inches. But 36 plus 4 will give you 40. So it's also the same thing. So 1 meter is 40 inches. And then we have 1 meter is 40 inches. And then we have trouser length. You know, the popular trouser length. And when you go to the market, you want to buy trouser length fabric. The trouser length fabric is in 45 inches. So one trouser length is in 45 inches. 45 inches trouser length is also 1 1/4, 1 1/4 yard. So 1 1/4. How do I come about this? 1 yard is 36. 36 plus quarter yard, which is 9, is also 45. So this is also one trouser length, 45 inches. And one trouser length can also be seen as 1 yard and 9 inches. So by the time you do 1 yard, 9 inches, add them together, you get 45. However, it's also one trouser length. And then we have 1 feet. 1 feet is 12 inches. So that's how it works. So let's quickly just explain just a little bit so that we're sure we understand what we've been working on. So this basically works. It's good to understand your tape very well. Let me just draw out this. I hope you can see. Just want for us to test it. So we have test what we've learned so far. Okay. So this is, if you check now, how do you know where this falls? You just need to count. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8. So that means this is 1/8. So I just drew out how 1/8 is, but I just want us to understand what it is. So let's say here is A, here is B, and this is C. Now we say, what is A to B? That means calculate it and tell and say the value. So let's just explain. A to B. Now if you check it, normally if you want to count, you go and count this as 1, 2, 3, 4, 5. No, it doesn't work that way because it started from here. Now it didn't start from here, it's from 0. It's starting on the first linear marking. A to B, that means you're gonna be, this is 1/8, don't forget. That means you're gonna be counting here as 0. This is 0, 1, 2, 3, 4. I'll repeat again. Normally your 0 is here, the edge of your tape, right? So you can't call the A because it says give what is A to B. That's the question. The question is what is A to B? A to B, your 0 must count first because you're doing 0 to the next distance. That's 1, 2, 3, 4. Let me explain. You have 0 at the edge of your tape. Don't forget, each of your tape starts from somewhere. Now you have 0. So from here to here, the distance is what we are measuring. You're measuring here to here as 1, here to here as 2. Now, if you miss this edge and you decide to start your counting from here, this is going to be 0 because you need to measure a distance here to count as 1. So here to here will now become 1. So that's exactly what we have here. So it says A to B. What's A to B? So that means you have to count 0, 1, 2, 3, 4. And this is 1/8. Now, under 1/8, if you miss, once you get your 0, you start counting 1, 2, 3, 4. That's half an inch. So that means A to B is half an inch. That's 1/2. A to B is 1/2. Okay, next, moving on. Now let's look at B to C. Now B to C, you have to calculate. Now from B, now you start 0. This is 0. This is 1, 2, 3, and this is 1/8. From B, you can count it. 0, 1, 2, 3, and this is 1/8. So we go 1, 2, 3. That's 3/8. So B to C is 3/8. So that's how it works. So if you come across anything like this, always can start from 0. So B to C is 3/8. Now let's look at A to C. A to C, you count 0. From 0, you go 1, 2, 3, 4, 5, 6, 7. That's A to C is 7. So A to C is gonna be 7/8. If you count 1, 2, 3, 4, 5, 6, 7, that's 7/8. So A to C is 7 over 8. Had it been A was at the edge, had it been A was at the edge now, that means we call here as 0. But because A is on the first linear marking, so that means we need to start, that means your calculation starts from 0. So you go 0, 1, 2, 3, 4, 5, 6, 7. That's 7, 8. So that's how it works. Please don't forget to subscribe, like, and give a thumbs up. So you can drop your comments in the section below. Thank you, and see you in our next video. Bye.